Welcome back to another video by Adeptis Academy. Imagine a special box that makes electricity from hydrogen and air, no smoke, no noise, just clean power. It might sound like science fiction, but this technology is real and already changing how we think about energy. Picture a device that sits quietly, with no moving parts, and produces electricity as long as you give it fuel. That box is a fuel cell, a tiny, super clean power plant. It's compact enough to fit on a table, yet powerful enough to run cars, buses, and even buildings. All fuel cells work by turning fuel directly into electricity with impressive efficiency. Instead of burning fuel, it uses a quiet chemical reaction. Hydrogen and oxygen meet across a special membrane, releasing energy. No combustion, no pollution. The only byproduct? Pure water. No harmful gases, just clean water vapor. Around the world, scientists and engineers are making fuel cells more affordable and powerful every day. Think of a fuel cell as an energy converter, transforming hydrogen's chemical energy directly into electricity with less wasted energy. No moving parts, no plugging in, just keep feeding it fuel, and it keeps working. Unlike batteries, fuel cells generate energy as needed. Just add more hydrogen and you're good to go. And unlike engines, they don't burn anything. No fire, no explosions, no harmful emissions. The most common type uses hydrogen, powering cars, buildings, and even spacecraft. Fuel cells are efficient, clean, and could change how we power our world, working alongside renewables for a cleaner future. Understanding them is the first step toward a healthier planet for everyone. Let's break down how a fuel cell works to see how it transforms simple elements into usable power. Fuel cells generate electricity without combustion, making them a cleaner alternative to traditional engines. At the heart of every fuel cell are three main parts: the anode, the cathode, and an electrolyte between them. Each plays a crucial role in converting fuel into energy. Hydrogen gas is supplied to the anode, while oxygen from the air goes to the cathode. These are the essential ingredients for the reaction. A catalyst at the anode splits hydrogen into protons and electrons. The electrolyte lets only protons pass to the cathode, forcing electrons through an external circuit. As electrons travel through the circuit, they create an electric current. This is the electricity we use. This flow of electrons can power cars, buses, laptops, or even buildings. Fuel cells are incredibly versatile. At the cathode, protons and electrons reunite with oxygen, producing pure water and a little heat. No harmful emissions. With no moving parts and no combustion, fuel cells are reliable, quiet, and require less maintenance. That's the magic of fuel cells. Clean, on-demand electricity that can help power our cities, homes, and vehicles. People often confuse fuel cells with batteries, but they're actually quite different in how they work and what they can do. Both are essential for powering our modern world, but their roles and capabilities set them apart in important ways. Batteries are familiar to all of us. They store energy inside, ready to be used whenever we need it. As you use a battery, it gradually runs down, releasing the energy it has stored until it's empty. Once a battery is empty, you either recharge it by plugging it in, or you replace it with a new one. This cycle of charging and discharging is what makes batteries so convenient for portable electronics and everyday gadgets. Fuel cells, on the other hand, work in a completely different way. Instead of storing energy, they generate electricity on demand, as long as you keep supplying them with fuel, usually hydrogen and oxygen. Think of a battery like a can of soda. Once you've finished drinking, it's empty, and you need a new one or a refill. A fuel cell is more like a soda fountain. As long as you keep the ingredients flowing, you can keep pouring drinks. In the same way, a fuel cell keeps producing electricity as long as it has fuel. Refueling a fuel cell vehicle is quick and easy, much like filling up a gas tank at a regular station. It only takes a few minutes to get back on the road. In contrast, charging a battery-powered vehicle can take much longer, sometimes hours, depending on the size of the battery and the speed of the charger. Fuel cells are also much lighter than batteries for the same amount of energy. This makes them especially useful for big vehicles like buses, trucks, and even trains, where weight and quick refueling are critical. Batteries, on the other hand, are perfect for small devices like smartphones, tablets, and laptops, where portability and convenience matter most. But when it comes to applications that demand long run times, heavy loads, or fast refueling, like forklifts in warehouses or vehicles traveling long distances, fuel cells really shine. The key difference comes down to how they provide power. Batteries store energy for later use, while fuel cells generate electricity continuously as long as they have fuel. This unique ability to provide steady, reliable power makes fuel cells a great choice for demanding jobs in industry, transportation, and beyond. That's why fuel cells are gaining ground in transportation and industry, offering new possibilities for cleaner, more efficient power in the years ahead. Fuel cells are key players in the clean energy revolution. Using hydrogen, they produce only electricity, heat, and water, no harmful emissions. No carbon dioxide, no smog-causing pollutants. They're much more efficient than traditional engines, often doubling the efficiency. Fuel cells come in all sizes, from tiny devices to massive power plants. They're quiet, making cities more peaceful. Hydrogen can be made from water using renewable energy, creating green hydrogen. This lets us store solar and wind energy for use anytime. Fuel cells help solve the problem of intermittent renewables. They're versatile, scalable, and clean. From cars to hospitals, they fit almost anywhere. Fuel cells are a crucial part of a sustainable energy future. They're helping us build a cleaner, quieter world. There are several types of fuel cells, each with its own strengths. Proton exchange membrane, PM. Fuel cells are common in cars, compact, and quick to start. Solid oxide fuel cells, SOFCs, run hot and are great for factories or data centers using various fuels. Molten carbonate fuel cells, MCFCs, can even recycle carbon dioxide from power plants. Phosphoric acid fuel cells, PAFCs, are reliable for stationary power. Alkaline fuel cells, AFCs, powered NASA's Apollo missions. Engineers pick the right type for each job, from vehicles to space. Fuel cells aren't just futuristic. They're here now. Hydrogen fuel cell cars are on the road, especially in places like California and Japan. Cities use fuel cell buses for clean, quiet public transit. Warehouses rely on fuel cell forklifts for non-stop operation. Hospitals and data centers use fuel cells for backup power. Some neighborhoods run entirely on fuel cell systems off the main grid. Remote stations and even ships are adopting fuel cells. NASA still uses them for space missions. Fuel cells are already making a difference in many industries. You might encounter one sooner than you think. Fuel cells offer big benefits: clean energy, high efficiency, and quick refueling. They boost energy security by allowing countries to produce hydrogen locally. But there are challenges: high costs and the need for rare materials like platinum. Infrastructure is another hurdle. We need more hydrogen stations. It's a chicken and egg problem. No stations, no cars, no cars, no stations. Safely producing, storing, and transporting hydrogen is complex. Costs are dropping as technology improves, but barriers remain. Overcoming these challenges is key to widespread adoption. The potential rewards make it worth the effort. Imagine a future where fuel cells power our cities, vehicles, and homes. Streets are quieter, air is cleaner, and smog is a thing of the past. Local fuel cell systems keep neighborhoods running, even during storms. Solar and wind energy create green hydrogen for use anytime. Trucks, trains, and ships run on hydrogen, slashing emissions. Refueling is fast and easy, keeping travel convenient. This future is possible with continued innovation and investment. Fuel cells aren't a cure-all, but they're a vital part of the solution. By combining them with other clean technologies, we can build a sustainable world. The journey to a cleaner future starts with fuel cells, one clean electron at a time.